Picture this, the one moment you have all been waiting for, where your dino collides into your incoming cactus in our endless runner game. You may ask, how do we actually get this done quickly without any custom code? Well, I have some tricks for this, but before we get onto this, let's add a ground beneath our characters to give it more depth. Create a new image style for your stack set to infinite width and height and image source to asset. Also ensure that it is kept at the bottom of the stack so our characters are not hidden behind it. Then we suggest using the box fit to contain and setting the image alignment to X as 0 and Y as 1. Of course, as you might have noticed, the characters need to be slightly raised to create the illusion that they are standing on the ground. The appropriate Y value for this adjustment may vary depending on the height of your images, so a bit of trial and error is in order. For the cactus, I have found that setting it to 0.45 works well. As for the dino, a setting of 0.5 seems optimal. We'll link this back to the Y alignment variable, allowing it to derive its value directly from this variable. To accommodate the new height, I am also updating both the player Y alignment and player initial Y to 0.5 in the page state variables. Let's run it and see it for ourselves. As you can notice, the dino doesn't seem to be jumping as high as it was before, right? So to rectify that, let's set a new max jump height to minus 0.5 instead of 0. Since we cannot declare negative initial values when setting up page state variables, we will need to add an on-page load action to the home page and reset the variable to minus 0.5. And with that, we are ready to dive into the collision detection logic. We pay close attention to both the X alignment of cactus and the Y alignment of the dino and observe the exact points where the cactus meets the dino. We need to note down the coordinates at which the cactus meets the dino, when it's idle and when it's attempting a jump over the cactus. You can experiment here and the values might differ from you depending on your character size. Remember to note down all these coordinates because that's the trick to our quick collision detection logic. When we have all these details, we plug our alignments back to the original values and proceed with our logic. On your start button on tap, just after you updated the increment logic for the cactus, insert a conditional action with multiple conditions, and each condition is mapped with an AND operator. There will be 4 conditions, which are cactus X alignment is less than equal to minus 0.9 and cactus X alignment is more than equal to minus 1.2 and player Y alignment is less than equal to 0 and player Y alignment is more than equal to player initial Y. When these conditions are met, we can conclude that there is a collision between our dino and the cactus. If these conditions are true, then stop both periodic actions, one for the player jump and other for cactus movement. Now let's test it and we see that it is working correctly and both movements were paused on collision. Ideally, we will end the game here and show a dialog for game over, but let's do that later. For now, let's add some improvements to this flow, like there is no way to restart the game again after collision. Let's go back to our builder and create a column of buttons. Now we add a similar button just below our start button. On the tap action of restart button, we should reset the values of cactus X alignment and player Y alignment, so it goes back to its initial state. After this, we can ensure that the cactus is back to being idle by stopping the cactus movement periodic action. But we are not done yet. To enhance the depth and illusion of movement in the game, let's bring our ground to life by making it move at the start of the game. And we can simply use animations here. Create an animation under action trigger. We will add a slide animation with a linear animation curve. You can experiment with the duration, but we will start at 3500 milliseconds. Here we are only altering the horizontal slide values. starting at an initial position of 0, which is its current location, and ending at -1440, which matches the width of the screen I'm using. Upon playing it as expected, it animates to the edge of the screen. But this does not look right, of course, as the ground ends at some point. So, how do we show that this is in a loop? There might be many ways to do this, but I have a quick trick here. If we have two such duplicate ground images and one is placed right at the end of the right frame, and we move both the ground images from right to left, at some point the first ground image will be at the left corner and no longer seen. At this very point, we can bring back the first ground image back to the left corner edge and do the same when the second image ends, and this will create a loop effect. Let's head back to our builder to give this a try. Duplicate the first ground image and place it right after, so it is easier to work with. You can call the new one anything. I am renaming it as ground back. Now let's update the animation settings. It will be similar to the first one. However, instead of starting at 0, it will begin from the opposite right corner, so we set it to 1440. It then returns to 0 as our final position. Before I run this, I will hide the ground front image so we can clearly see the animation results. And now let's preview the animation. As you can observe, it starts from the corner and completes the entire width. Now let's unhide the first image and play the animations together. And together these create the illusion of a moving ground. To create an endless effect, we will have to loop this animation. So now at your on tap of start button, just before your periodic action, add a new action for widget animation. Specify the front widget first, ensure the loop animation is on, and set to non-blocking, as we do not wait for this action to complete before starting the next animation. Copy and paste the same action again, and this time the widget animation is for ground back widget, having the same settings. Now watch the magic happen as our ground moves continuously. It's important to know that this setup isn't very responsive to different screen widths since we have hard-coded the position to 1440 in the animation properties. Additionally, you can also apply the same logic to the clouds. Feel free to adjust the duration or speed of the animations as clouds don't need to move at a consistent speed. And that's all for now. This is how we incorporated collision detection into the game and introduced moving backgrounds. Stay tuned for our next video where we will add even more exciting features to this game.